as you can see, in case you don't know, the circuit above is a series and parallel combination. So you have the resistor labeled from R1 down to R4. So the R2 and the R3, they are parallel connected. Then you have the R1 and the R4, they are in series all together form the circuit. And you are given the potential difference. It is the EMF of the circuit is available there. So when you have a circuit whereby the resistor is there and you have the PD, you think about the current. And before you get the current, you must determine the resistance of the circuit. That is what the law says. Remember the law? V equal to IR. So you have the PD given, that is 24 volts. So the current is what you don't have. Then you need to find the resistance before you can get the current. So the resistance is the deposit from the resistor. So let's get the resistance now. So the resistance calculation, you start from the parallel combination. You resolve the parallel combination, then you add the result to the series connection. So from parallel combination, so you have 1 over R total, which is equal 1 over 4 plus 1 over 12. 1 over 4 plus 1 over 12 will give us what? That is 4 over 12. So you get the LCM. So the LCM of 4 and 12 is 12. So 4 in 12, that is 3. 3 times 1 is 3. 12 in 12, that is 1. 1 times 1 is 1. So 3 plus 1 gives us 4. Then you have 4 over 12. That is the addition there. Then R total in parallel will now be 12 over 4, which is 3 ohm. So from the parallel connection, the resultant there is 3 ohm. Then the 3 ohm is now in series with R1 and R4. So the total resistance in the circuit will now be R1, which is 5, plus R4, which is 8, plus the parallel connection, which is 3. Everything will give us 16 ohm. So there are 16 ohm resistor in the circuit. So you can easily access the current now. So from the formula, I equal V over R. So make current is master of the formula. So the V is 24. So you have 24, then you have the resistance, which is 16. So everything will give us 1.5 ampere. So there are 1.5 ampere in the circuit. That is it. So you have the PD 24, you have the resistance, which is 16, then you have the current flowing in the circuit. So the job is moving. Then you need to know the current here. The current here, the PD 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 here. So I want to see how the current will circulate and how the PD will drop in those resistors. That is our next target now. Now from here, so we have the 3 parameters. Don't forget, we have the 3 parameters available. So current is available. We have the resistance total 16 ohm. So we have the current in the circuit, that is total current 1.5 ampere. So and we have the EMF, that is a PD, which is 24 volts. That is what we are going to use to do the calculation. Then for R1, the current will emanate from the source. The current is flowing. The current is flowing. So the current will pass through the R1 resistor. So you can see that I1 equal 1.5 ampere. R1 is in series. So series, the current is 1.5 ampere. So the current is moving. You can use this current to find the voltage now. So the V1 there will be I1 times R1. That is the V1, voltage in the 5 ohm resistor. So you go on and say the I1 is 1.5 times the R1, which is 5. So you multiply them together, so you have 7.5 volts. That is it. 7.5 volts is what you have here. Then the voltage out of 24 voltage you have in the system. So 7.5 has dropped into the 5 ohm resistor. Then you count the remaining one will be moving. Then when the current reaches these points, the current will divide. Then you have some through the R2, then some through the 12 ohm resistor. So to know the current here now, let me say I2. I2, take the resistor of R3, which is 12, then add R2 and R3 together. 4 plus 12, that is 16, times the total current, 1.5. So you resolve this problem. 12 times 1.5, then divided by 16, you have 1.125 ampere. That is 1.125 ampere is what you have in the 4 ohm resistor. So use it to get the voltage. So the V2 voltage in the second resistor will be I2 times R2. So you go on and say I2 1.125 times R2, which is 4. So you have 4.5 voltage. That is 4.5. So 4.5 drop here. Don't forget it was 24, then 7.5 drop here, then 4.5 drop here. So let's come to this one now. So let's see the current here now. So the current here is the next target. Current in I3. Use the R2 resistor 4 over the total, which is 16, times total current 1.5. Then you solve the problem. 4 times 1.5 over 16. So you gotta have 0.375 ampere. That is what we have. 0.375 ampere is what we have. Then use the current here to find the voltage here. So V3 now will give us I3 times R3. That is what you have. Then you come down and say the I3 0.375 times R3, which is 12. When you multiply them together, so you will have again 4.5 voltage. So you can see by yourself that when you have resistor connected in parallel, so the voltage is the same thing, either big or small. As you can see here now, the first one is 4 ohm resistor and the second one is 12 ohm resistor. They are connected in parallel, but the voltage drop is the same thing, which is 4.5. Don't forget, out of 24 voltage, 7.5 has dropped here. Then the parallel one, they attract 4.5. The remaining one is what the R4 will take. Now, we got it now. So you have the currents, you have the voltage. So the currents, they will come together again. They will merge at this point, move together. So the current is moving. Or the current will flow through the R4 resistor. So you can easily see that the R4 is also in series. So your R4 there now, your R4 there will be R4 now. I4 will also be 1.5 ampere. No calculation because it's in series. So when you have resistor in series, either big or small, the same current flow. Let's see the voltage. So the voltage, which is in V4, will now be I4 times R4. So you have I4 1.5 times R4, which is 8. When you multiply them together, you have 12 volts. So you can see now. So the voltage is not the same thing. For a resistor in series, the same current regardless the size of the resistor. So the voltage is not the same thing. But one thing is certain. So the smaller the resistor, the smaller the what? The voltage. So the story is not the same thing when you have parallel connection. For a resistor in parallel, so you must have the same voltage drop regardless the size. But one thing is certain, the smaller the resistor, the bigger the current in it. Then if you are to determine the power supply, because when you have a circuit of resistor and you have a PD, so there's no doubt, so they may have to determine the power supply. So the power supply in that circuit power is equal to high V, just like that. That is equal to high V. So you have the high, the circuit, which is a current 1.5, then the V is the PD 24. So you have 36 watts. That's the power supply in that circuit. So nobody will have to determine the energy stored because resistor don't store energy. Resistor don't store energy. So the only power, energy isn't there. I think that is the end of the calculation. So our next class will be on capacitor, which is the exact opposite of resistor. Thanks for watching.